Okay, this is going to be the last video on naming ionic compounds, and it has to deal with those polyatomic ions that you've been memorizing. Okay, so what is a polyatomic ion? This is going to look different than our binary ionic compounds that we've been talking about. So if you just break down the word polyatomic and what it means, hopefully you know means many. Atomic, obviously, that's talking about atoms. And then ion means that it's charged, meaning it's either gained or lost an electron. Okay, so these guys, we're actually going to consider them like a singular atom, but they're kind of connected together, okay? Now you may remember covalent bonds, you may not, but I'm just going to say this in case you do remember this. They work because NH4 plus is going to act like an ionic compound, but the rest of it is going to act like a covalent compound, meaning the nitrogen is actually bonded to 4 hydrogens and has lost an electron from that covalent bond, okay? And we'll talk a little bit more about that in class. So how do I write the formulas and how do I name them? Let's do formulas first. First, you need to know the charges. If they don't cancel, you'll crisscross if necessary. And then if there's more than one polyatomic, you're going to need parentheses, okay? Because poly means many. So just like in math class, if we want to distribute to a whole system, we have to put that system into parentheses. All right, so it's kind of the same concept here. And I'll show you an example here in a minute. Okay, so let's look at these sodium hydroxide and calcium hydroxide. So sodium is Na, it's in group 1, therefore it'll have a +1 charge. And you should know that hydroxide is OH minus 1. Okay, so this is that group that I was talking about. So O and H are attached. We can kind of think of it just like sodium. It's just one element. They're together. Okay? +1 and -1 charges cancel. So to write this formula, it would just be NaOH, or sodium hydroxide. Okay, that one's easy because the charges cancel. What about the next one? Calcium's in group 2, therefore it'll have a +2 charge. Hydroxide still has that grouping, or that -1. Okay, this time charges don't cancel, so the 1 will go to calcium, and the 2 will go to the hydroxide. Okay, now this is what I was talking about with the parentheses. Calcium has that one subscript, right? And then I need to write OH2. Now think about this for a second. If I don't put this polyatomic ion in parentheses, this 2 just indicates I only have 2 hydrogens. However, I also have 2 oxygens, and that's why I need those parentheses there to indicate that I have 2 oxygens and 2 hydrogens, okay? And that's kind of what I'm talking about with the parentheses. So that's how you write the formulas. To name them, you're always going to name the cation first, and then if the cation is a transition metal, what do you need to remember? You need a Roman numeral. Right? Most, and then you do the anion or the polyatomic, and most will end in ate or ite. So SO4 -2 is sulfate, where SO3 -2 is sulfite. Okay, so let's just do a couple of examples here. Sodium, is it an always charge or wishy-washy charge? It's an always charge, it's always +1. Therefore, I can write sodium, and then you need to know that SO4 is sulfate, so this would be sodium sulfate. Okay? Silver, always or wishy-washy. Silver's an always, that's one of those +1 charges that I need you to have memorized. So this is going to be silver. NO3 is nitrate. So it would be silver nitrate. Okay, iron, always or wishy-washy. This is going to be a wishy-washy charge, okay? So now I have to figure out what iron's charge is here, okay? PO4, you should know that PO4 is phosphate and has a -3 charge. Okay, so if I do my math here, I'm going to say I have 1 cation times its X charge plus 1 anion times its -3 charge is going to be equal to 0. Okay, so if I do this algebra here, this will be minus 3 is equal to 0. So X is equal to plus 3. So what is iron's charge in this case? Iron's charge is going to be 3. So I have to write iron 3 phosphate. You could also remember that if phosphate has a -3 charge and you don't see any subscripts, that's going to mean that iron's charge has to be plus 3. All right, let's do one more. Cobalt, always or wishy-washy. It's in that transition metal group, so this is going to be a wishy-washy. So I'm going to do kind of like the other way that we can name transitions by uncrisscrossing. So CO3 is carbonate, and I do know that it has a -2 charge, therefore I can uncrisscross and everything will be fine. So this is cobalt 3 carbonate. Okay? And that's how you write names from formulas. Okay, let's do a few more examples since I have some time here, and then I'll let you practice on your own. All right, so let's write the formulas for iron 3 sulfite. Okay, so iron is plus 3. Sulfite is SO3 minus 2. Charges don't cancel, so I have to crisscross. So this will be Fe2 SO3, and then I need to make sure that I'm putting that 3 in parentheses. Okay, let's do one more. Ammonium sulfide. Okay, ammonium is NH4 plus 1. Sulfide is just based off of the periodic table. Ide means it's been pulled off the periodic table, so this is just sulfur with a -2 charge. Charges don't cancel, so I'm going to crisscross. So this is going to be NH4 in parentheses 2S. Okay, so that's how you name polyatomics. Thanks.